All right, everybody. So for lecture 9.2, we're going to look at muscle anatomy and physiology. And who knows, maybe we'll change this lecture number in the future. So this basically is going to be some videos about muscle anatomy and muscle physiology. What we're going to do is we're not going to look at the comparison between skeletal, cardiac, and smooth muscle. That's something that I want you guys to do on your own, and then think about posting your chart for your comparison on the discussion forum. Okay. But what I'm going to do is I'm going to help you with drawing and labeling a skeletal muscle organ, a fiber, and a sarcomere. So basically, I'm going to draw the whole muscle from big to small and label everything so that you can see it a little bit better. And then I'm going to go over synaptic transmission to a muscle fiber, and that's going to start the contraction of our skeletal muscle fiber. Basically, it starts the contraction of our sarcomere, okay? So we're going to then look at how a skeletal muscle fiber, and that really probably should say the sarcomere, how the sarcomere actually contracts. Once you've sent the message down a motor neuron, what happens inside of the muscle cell in order to make the sarcomere contract, and then every other sarcomere contract so that your muscle gets smaller in its contractility, okay? So let's start with the easy part. This is not the easy part. This is still the hard part. But I always have students who come and are really confused about drawing a skeletal muscle organ, and I always draw it out for them, and it usually helps a little bit. So you're just going to draw yourself a bone here. If you can draw a femur, hopefully you can draw a femur better than I can. You can draw like a femur. If not, then don't worry about it and just basically draw a line as a representation of your bone. But your femur is going to have like a nice big greater trochanter right there, and then your head and your neck, and then you're going to come down to the shaft area. And again, my drawing is not that great. It's much better on a whiteboard. I have more control with my hand. So we're going to see that we're going to take a muscle that comes off of our bone, and essentially our muscle that's going to come off our bone is cylindrical, okay? Not all muscles are cylindrical. Some of them are flat, but it's easier to actually do it this way. We're just going to draw a nice big circle here, and hopefully I have enough room for all of my cylinders, and I'm going to pull that back. And what I'm going to see is this is my skeletal muscle organ. So just imagine like this is one of the muscles of the thigh that I cut through, okay? And I'm going to make all of my connective tissue in blue because I usually do that. So the connective tissue that wraps around the entire muscle organ, holding everything together, is called the epimysium. And what it's holding all together inside is, I probably should have made a little bit of a white area when I drew this, but I'm just gonna erase maybe just a little bit right there, and I'll fill back in if I need to. So the skeletal muscle itself is going to be made of cylinders that all run parallel to each other and give us the striated or the pinstripe patterning that we see of our muscle. And I'm just going to pull out one of these cylinders here so that we can see it a little bit better. And good thing I did all that white because I need a little bit more, right, like that. Okay, so each of these cylinders that we're drawing would pull all the way back. So I want you to think about that pulls all the way back like this, and it creates the pinstripe pattern that we're going to see that's part of our organ. You're going to use those fascicle patterns, which I haven't called them that yet, to help you figure out one muscle from another muscle, okay? So this cylinder that I pulled out that I'm going to kind of do a wrap around here is the fascicle. Okay. The fascicles are all held together by the epimysium. Then surrounding each fascicle is going to be more connective tissue called the perimysium. So you want to think about the perimysium is going to come all over around each one of these cells, basically. And it pulls all the way back along with the epimysium, and all that connective tissue is going to come together at the end of the muscle, and that ends up forming our tendons. So those are the tendons that attach the muscle to the bone itself. And so this is going to wrap all the way around. This wrapping around the fascicle is called the perimysium. I guess you call it mysium, but I always call it the mysium. Then inside of our fascicle, we're just going to erase a little piece here so we can pull out another cylinder, okay? So again, there's going to be smaller cylinders inside of here. So the smaller cylinders that are going to be inside of the fascicle are the muscle fibers. So these are our cells. Okay, so this is our muscle fiber. Just like that. And superficial to our muscle fiber is going to be another type of connective tissue that wraps all around it and goes between each one of these muscle fibers, and that's the endomysium. Okay. We're not done yet. We're just getting really small. So when we get too small, then I'm going to make our small stuff a little bit better. And I forgot a little bit of endomysium, like right around there. So we're going to have more cylinders inside of here, which is going to be really small to draw, but like that. So we're going to have more cylinders inside. And this cylinder that makes up the muscle fiber is the myofibril. Okay. The myofibrils are going to be made of more cylinders. But the next thing that's going to make up your myofibril is going to be individual contractile units of the sarcomere. So we're going to continue our drawing by actually drawing the myofibril and the sarcomere itself. And I was just going to do that because I'm weird like that. Okay, so this is our big to small. And let me put my label over here. I just want to put my label over there because then it makes a nice like flow actually from one thing to another thing. If you're wondering what goes over the myofibril, what will go over the myofibril is going to be the sarcoplasmic reticulum. But let's not draw that on there so you guys don't get confused about, levels here. The connective tissue levels are a little bit different than the stuff that's going to be inside of the cell. So then I'm also going to draw the muscle fiber bigger so that you see what's inside the muscle fiber, what's the myofibril look like, and what does a sarcomere look like, along with what do the myofilaments look like. So if you really wanted to go one level deeper, you're going to see that there's going to be two different fibers here, or filaments, filaments. We're going to have these as being our myofilaments. The myofilaments are going to be actin, which makes up the most of our thin filament, and the myosin, which is going to make up most of our thick filament. And that's why I tried to make one thicker and one thinner right there. And that makes up our myofibril. It really makes up the sarcomere, which makes up the myofibril. Okay. So the next video, I'm going to take the muscle fiber, I'm going to make it bigger.